Thank you. Okay, here we go. First of all, the energy of the photon is Planck's constant times the frequency, which is the same as the speed of light over the wavelength. So I got 10.2 electron volts. You guys good with that? Yeah. Okay, but now we've got to find the energy level. And we know that n equals 2 is negative 13.6 electron volts, and n equal 4, that's what we're trying to find, but you know you lost 10.2 electron volts to get from there to there, and I'm just kind of trusting on your ability just to do arithmetic in your head. I mean, I could give you, it's always E2 minus E1 or E prime minus E, but I mean, just use your cleverness. I mean, if you lost 10.2, then this guy must have been negative 3.4, right? Then you subtract 10.2 from it, you get negative 13.6. If you prefer, you could always do x minus 10.2 equals negative 13.6, and then that'll get you your answer. How many people got the negative 3.4? Okay, yay. That's the last time you're ever going to use that negative 3.4, though. The rest of the problem is the 10.2 that's going to matter. So the momentum, you got this, and I didn't want to do it, so what did the momentum end up being?
5.4 times 10 to the negative 27.
Okay, 5.44?
Yeah.
Times 10 to the negative 27?
Yeah.
23.
And that's kilogram meters per second. You got to make sure you give the units on this exam, because there's so much confusion about electron volts versus joules. You know? And then this guy, okay, so now this 10.2 electron volt photon is going to hit some silver with a 4.7 electron volt work function. So did you get the maximum kinetic energy being 5.5 electron volts? How many people got that? Yeah, and they didn't even ask you to find the speed of the electron. They were happy just knowing its energy. So we're done, and now here comes the tricky part. You've got an electron with 5.5 electron volts of kinetic energy. What's the stopping potential?
5.5 volts.
5.5 volts, yeah. 5.5 volts.
Too good.
5.5 volts of electric potential difference times the one electron makes a work of 5.5 electron volts of work. And that's going to stop your 5.5 electron volt electron.
Why would that be tricky?
What's that?
It's called sarcasm.
Oh. I didn't realize you were being sarcastic, and I thought you were like serious, like, oh, here's the tricky part, and I'm like...
Okay, so hey you guys, so can I show you one more thing? There's actually, keep it on because there's one thing I forgot to tell you. This is totally like out of order, out of context, but I forgot to mention this, okay? You've got emission spectrum. These are the photons that your atom is going to give off. Tell me, when your atom is giving off photons, are these electrons falling in energy level or rising in energy level? Yeah, they're falling. When you fall in energy level, you give off a photon. And so that's the emission spectrum. And that's the one where you'll get, you know, this red and that red and this blue and that blue and maybe this green, that sort of thing. That's your emission spectrum. That's when the electron falls in energy level. Well, we've got another type of spectrum called the absorption spectrum. Absorption? Absorption?
No,
that's
absorb.
Is it absorption?
No.
Watch me look at it.
That's absorption.
Hey, where's my notes? Just a second.
Absorption. Like a salt squid. What? Absorb? Should. It's like a salt squid. Like a salt squid. Salt squid.
Well, whatever it is, who cares? I'm so sorry. How do you spell absorption?
That's
It's
good.
a P.
Oh.
It's a P.
Absorb.
P.
Yeah, it's a P.
Who's telling me B?
Tim, Johnson, what the heck? Yeah, Johnson, what are you doing? Johnson, it's a P.
Okay, And the absorption spectrum, here's what I want you to imagine now. You've got this gas, and you're bombarding it with white light. You're bombarding this gas with light of all frequencies, right? And you're standing on the other side of this gas to see what frequencies of light are going to hit you. And now, what you're going to get is, you're going to get all of the reds, except those two little frequencies that get absorbed, which is the same frequencies that get emitted. I mean, if you drop from one energy level to another energy level and give off a photon of a certain energy, then to rise up to a higher energy level, you must receive a photon of that same energy, correct? So your absorption spectrum is going to look like this. You're going to have all of your red except those two frequencies that it absorbs. And like you'll have all of your green and orange and yellow, except for that green frequency that it absorbs, because the frequency of light that it gives off is the same as the frequency of light that it has to take in order to rise an energy level. You see? So this is your absorption spectrum, and this shows you where the gaps are. The gaps are frequencies, goodbye Chris, frequencies of light that are absorbed, and this is going to happen when your electron rises energy levels. Happens to make the electron rise energy levels. So here you're seeing what light is given off by the gas. Here you're seeing what light does the gas absorb. And so what if I gave you an energy level diagram that looked like this? Okay? And on this energy, let's say n equal 1, n equal 2, n equal 3, n equal 4, and I was drawing these arrows. And I were to find the frequencies or the wavelengths of all of these photons, and I happen to know the energy level. Maybe this is -30, and this is -20, and this is -10, and this is -5, I don't know. So I were to find all of these wavelengths, what would I have here? Is this an emission spectrum or an absorption spectrum?
Emission.
I don't know.
Absorption.
Good, absorption. I'm hitting my gas with light. My light is absorbing the energy from these photons and bumping up energy levels. So this would be an example of an absorption spectrum. I want to write B for my absorption spectrum. And of course, if the arrows were the other way, now you've got your emission spectrum. So I just want to make sure you're aware of the difference between the two. With absorption, you're going up energy levels. With emission, you're falling energy levels. Yes, Brianna?
Will it ever show both, like absorption and
Yes.
emission at one time?
Yes, it will. Yeah, then you would say this guy's absorption and that guy's emission. Yeah. All right, hey guys, I recommend that you do all the problems on here that I've given. That's the only problems I'm assigning for atomic physics.
No.
I'll be collecting these on the day of your atomic physics quiz. Good luck, you guys.